Here's another example of a multiplication problem in which we have three factors, three quantities to be multiplied. Now, this problem has a little twist that makes it a little more intimidating, maybe we'll say. And that is that this fraction, its numerator, contains a decimal number. Now, we're not used to seeing fractions where the numerator or the denominator is a decimal number. We are used to seeing our fractions have whole numbers in the numerator or whole numbers in the denominator. So this kind of problem sometimes can present some difficulty. I want to show you one technique that's oftentimes used to make these kinds of problems appear at least less complicated, and that is to eliminate that decimal number. And I could do that by multiplying that quantity by 10. But remember, if you multiply a fraction's numerator by some quantity, you have to multiply its denominator by the same quantity so you don't lose the value, you don't change the value of that fraction. So I'm going to multiply the numerator and denominator of that fraction by 10, which means I've really multiplied it by 1. So I haven't changed its value any. Just look at that for a moment. If you have the fraction 2/5, if you multiply the numerator and the denominator both by 10, that gives you 20/50ths, which is the same value as 2/5. You haven't changed the value of the fraction, even though you've changed its appearance. 2/5 is a different appearance than 20/50ths, even though it represents the same quantity. If you had 2/5 of a candy bar, you'd have the same amount of candy if you had 20/50ths of the same size candy bar. So I don't change the value, I'm just going to change the appearance. And it's actually going to make my multiplication a little bit easier to perform. Well, 1.2 times 10 gives me 12. Remember, to multiply by 10, you just move the decimal point one place to the right. In fact, that's how I determined I was going to multiply by 10. I needed to get rid of one digit to the right of the decimal point. So I knew that multiplying by 10 would move that decimal point one place to the right, which would eliminate that decimal number. And 6 times 10 is 60. And now all of my fractions have whole numbers in their numerators or denominators, which should make my canceling easier than if I were to try to cancel with that decimal number there. Well, let's see what canceling we can do. Well, one thing I noticed, 8 goes into 8 one time, and 8 goes into 24 3 times. Let's see, 21 and 35 are both divisible by 7, aren't they? 7 goes into 21 3 times, 7 goes into 35 5 times. Oh, and actually 12 is a factor of 60, isn't it? 12 goes into 12 one time, and 12 goes into 60 5 times. And I think I've done all the reducing that I can do, so I'll multiply what's left. 3 times 1 is 3, 3 times 3 is 9. 1 times 5 is 5, 5 times 5 is 25. So the value, when I multiply those three quantities, is 9/25 as a fraction. Let's express our answer as a decimal. So we'd have to change this fraction into a decimal. And remember, the way you change a fraction into a decimal is you divide the denominator into the numerator. So the numerator goes under the old-fashioned division sign. Or if I were allowed to use a calculator, I would put the 9 in. I'd put the numerator in first, hit my division sign, put in the denominator, in this case 25, hit my equal sign to get my answer. But let's do it the old-fashioned way. So 25 won't go into 9. 25 goes into 93 times, giving us 75, which is 15 when we subtract, bring down the 0. 25 goes into 156 times. In fact, that is exactly 150, giving us a remainder of 0. So our answer as a decimal is equal to 36 hundredths. So the answer as a fraction is 9/25, as a decimal is 36 hundredths. What if we wanted our answer rounded off to the nearest tenth? Then we'd have to look here in the hundredths place, wouldn't we? And if the hundredths place is 5 or greater, we will increase the tenths by 1 and drop the hundredths value. So rounding off this value to the nearest tenth would give us a value of 4/10. Here's the value exactly. It came out exactly 36 hundredths. If we wanted to round and round to the nearest tenth, it would be 4/10 as a rounded value. So here's an example of the kinds of problems we'll be working with as we work through allied health math this quarter.